In part one of our video series, we had taken a look at getting some design specifications from a third-party website, in this case Home Depot, so that we could build a 6-port manifold. In addition to this, we also went on the McMaster Car website to extract some third-party CAD data for some of the important features. And then lastly, we had used the split tool to help trim off portions of the barbs that we didn't need. And so we had worked together on the half-inch barb, and I just did the same process for the 3/4 inch barb as well, and had encouraged you to do so on your own. Now, in this video, we're going to actually take these imported features and we're going to use these to create that 6-port manifold. So I'm just going to go ahead and start a new part file. And right out of the gate, the first thing we should always do when working on a project is to save the file. Save early, save often is just a great computer rule to live by. And before we get started bringing in those features, I'm going to go ahead and kind of set the stage. So again, based on the website, and you might want to keep that handy, we saw that the overall length of the part was going to be 15 inches. And we also saw some important other characteristics, like we saw the outer diameter of the tube was 1 1/8 or 1.125, and we also saw that the overall height of the part was 2.06 inches. I'll leave it like that, but I'm assuming they mean 2 1/16. So from there then we have to go ahead and make some assumptions based on the rest of the design. So there is a body length of the component, not just the overall length. And based on the fact that the 3/4 inch barb is about 0.75, just a little bit over 3/4 of an inch long as well, I'm just going to go ahead and create a new parameter called body length. This will be that main central tubular portion of the part. And I'm going to say that that equals, copy the overall length. I'm going to say that's overall length minus 3. Cool. Now, to handle the barb spacing, I'm going to also make another assumption because I don't have the part in front of me. I am going to assume that the spacing between them is equal, and I'm going to make a half space at each end. So not a full indent for spacing at each end. I'm just going to give a half indent. So what that does for me is it makes the barb count equal to the number of spaces. So I'm going to go ahead and add a barb count parameter, and I'm going to set this as being unitless. That's the UL. Now you can go ahead and navigate through the list to pick it, but if you just type in UL, we know that, or I should say Inventor knows that that is a unitless parameter. Then I can type in 6 and I've got my count. And then I also need some spacing, so I'll create a barb spacing parameter. Eventually we're going to need to make a pattern, and I'm going to say that that's body length divided by, and then we can also use the arrow at the right to list the parameters, and I'm going to say barb count. So that's the basic setup. Later on I'll add a parameter for the ID of the tube. I could do that now or through the modeling process. Either way is fine. I'll go ahead and hit done, and then once we've got that, again hit save or control S, and let's start to set the stage a little bit for our design. So we know that we've got a couple of things going on here. So we know that we have an overall length of the part, but because of the nature of the design, I'm only going to do half of it and then mirror the first half to the back side and then combine that as one part. So I'm going to use the XY plane for my origin as that middle plane. And the reason I'm doing that is because each of these barbs appears to have come in on the XY plane. So that just means I'll use the Z axis for my axial alignment. Should make this part relatively easy to create. And so what I'm going to do is I'm going to offset from the XY plane that overall length of the part. But in this case, since I'm doing half of it, I'm going to hit the end key, and I'm going to divide that by 2. So we're going to have this divided by 2, and then that would make the XZ plane, I'll kind of orbit my model a little bit, the XZ plane then would be the central plane of that tube. So what we could do is we could also offset this. This is going to be a little bit trickier, but we can offset the XZ plane with a formula. And we can list these, and let's say it's overall height, that's that 2.06, but since we're starting out halfway between, and this usually works, but sometimes I'll hit a quick Control C, because now what I have to tell it is I have to say minus half of that OD. So I'm going to say minus, and then I'm going to do this list parameters again, and I'm going to say OD. So now that formula is stuck. It's OA height minus OD divided by 2, because I only want to go half of that outer diameter, not the full. So that's the formula for the height of my half-inch barb eventually. And then I'm going to do one more offset from the XY plane. And again, since I'm treating, the XY plane, since I'm treating this as the mid plane, I know that if I go half of the barb spacing forward and half of the barb spacing backward, I'll get the full barb spacing. So what I'm going to do is I'm going to list my parameters. I'm going to go with barb spacing, but hit the end key and say divided by 2. And that's going to be my 3/4 barb. So again, we're just kind of setting the stage here for some of the design stuff. And now we're going to actually place some barbs, relocate them to their proper positions, and then we will create the additional features that we need to complete the part. So to bring in the external barbs, because I don't know the barb design, I don't want to really look it up, and I can extract it really quickly from an existing design, I'm going to go ahead and derive in those solids that I modified. And the 60 should be that 3/4 barb. I'm going to grab that one first and hit open, and it places it in position. Now, what the derive tool does is it allows me to grab geometry from outside my model, bring it into this model, and then I can pick and choose which features come across. I can also change colors, I can change the scale, I can mirror it. In this case, I'm going to keep it really simple, and I'm just going to turn off the work geometry. I don't need it. I only require the barb solid. And so then I hit OK, and now we've brought that barb in. And the really powerful part of the derive tool is if this barb had to change for whatever reason, like I had to modify it, it would update in this part. So this is another great technique for using sort of a quote unquote live link to the original models. So again, something pretty powerful about that. Awesome. So what we'll do next then is we will grab the barb here, and let's position it at the end. We'll just move this one right away before we bring in the other one. So I'm going to go ahead and grab the move bodies command. And what this does is it allows me to take a solid body and reposition it. Regardless of where you originally sketched it, or in this case where I originally imported it, I can reposition it using this move bodies tool. So it's a pretty powerful tool. It's a little bit quirky, like every time you launch it, it wants to move it in the X 1 inch right away. So that's a little strange, but it's still pretty solid. And so what I want to do is I want to translate for now, but I only want to translate along the Z axis. So to save time, I will select this first. If I don't do that, I'll not select it so you can see. And then when I use the measure option, I want to measure from the front face of my barb, to the plane. What happens is it just kind of leaves the text in place. So you'd have to delete it anyway. I just find it's easier to delete it right up front. And so that's it for this one. All we're going to do is we're going to stick the front of that all the way to the very end of the part. And now we've repositioned that 3/4 barb. Cool. So the next step in the process then is we need to apply the second barb. So if we come in here and we derive in the 3/4 inch barb, we can do a lot of the same stuff. So I hit the open. I don't believe I need any work geometry, so I'm just going to turn that off. And then I open it up, and there's our 3/4 barb. So we're going to have to reposition this as well, and that's where we have these additional work planes to utilize. So let's go ahead and launch that Move Bodies tool one more time. I'm going to grab the 3/4 inch barb this time. I don't want to offset it in the X. And instead of translating, what we actually want to do is we want to rotate it about a line, because the part, if you remember from the Home Depot website, or if you still have that up, which would be helpful, that barb is actually facing directly up, or it would open up to the positive Y in this case. So what I want to do is I want to rotate that then about the X. So if I rotate it about the X axis, now it would flip that up or down, in this case, to the right orientation. So you can set this to be -90, you could say 270. It doesn't really matter what you type in here as long as you get the orientation correct. And then I can go ahead and hit apply. And now I can do the rest of the motions to reposition this. So I'm going to go ahead and do a free rotate or translate again, not in the X. And then I'm going to again measure in the Z. So this time I'm going to measure from the XY plane. No, it's not visible. So let me turn that on here quick. So let's turn that on just for our reference. Cool. And now we'll launch that move bodies command again. This body, I don't want to move it in the X. And we'll move that along the Z. Select that first, do the measure, and now we can measure from plane to plane to move that in the Z. We like that. We hit apply. Select it again. Still don't want to move it in the X. And now we're going to offset this in the Y direction. So I'll select the text, measure, and we'll measure from the top to the very top of the part. So go ahead and hit OK. And so now we should have these components positioned exactly the way that we need them to be. So what I'm going to do then is I'm going to create the body of the part, and then we're going to readjust this component, or I should say we're going to add additional features to the component to kind of finish off the design. So what I will do is I will start a sketch. I'm going to start it on the XY plane, and we have some of the characteristics of the model based off of the spec page, and so I just named this OD, so it's just as easy to type it in and hit enter. And so that would be the outer diameter of the tube. Now what I don't have is the thickness. So I'm going to make an assumption because I could later on go back and measure it. But I'm going to go ahead and create a second circle, and then I'm going to right click, add in a general dimension, and I'm going to say thickness equals 0.0625 or 1/16, and hit enter. That's good enough for what I'm trying to do. I feel pretty good about that. So then I will right click, finish my sketch, and then right click, extrude, and I just want to extrude this tube as a new solid because we'll merge all these in the end. And I want that to go, let's see, body length, but again, since we're only doing half of it, I'm going to say divided by 2. Perfect. So now we've got this shape going on here, and then what we can do is we can add in a loft. So if I loft these shapes together, if they're not all one solid, you may get errors. Let me show you. So if I try to do a solid loft between two different solid bodies, it may or may not work. I've had it work occasionally, but I've also had it not work. And in this case, it worked, but we have a problem. It lofted a solid. So we would have to add a second loft, which is not a big deal. So I'll just loft it again. And this time I'll loft from the interior edge to the interior edge at the front end of my tube. And I want to do a cut. So if I hit apply or OK, now we've got that remedied. We can see through our tube again. Sorry, cut off my volume there. So anyway, just in case I missed that, if we look at the interior part of the tube now, we were able to remove that with the second loft. So now what we're going to do is we've got to obviously attach this barb to the tube. So really easy to do, and I'm going to use kind of an interesting tool called replace face. So if I use the replace face tool, it's under the surface panel. I can click on replace face. I'm going to grab this bottom of that initial barb, and then I'm going to click new face, and I'm going to make the outer diameter or the outer cylindrical surface of the tube the new face. I hit OK, and now it does that. So it does a straight up replacement, which is kind of cool. And then we have to apply a couple of features here to finish it off. So I will go ahead and I'm going to select this top surface, create a new sketch, plop in a circle here. Actually, sorry, right click, project the geometry first. Hey, there we go. Right click, finish. Don't even have to draw the circle. And then I can extrude that, choose the solid. I actually want to affect the tube. And then we're going to do a cut, and we'll do 2, and then we'll just pick this interior surface. So we'll cut it all the way through to the interior surface for that hole. Click OK. And then we actually have to mirror or pattern this out. It's a little bit quirky. Because this is a separate solid, I have to pattern this out. Then I can come back and combine it. Then I can add the fillet. So we're going to do this in a couple of steps. I'm going to do a linear pattern or rectangular pattern. I'm going to grab a solid this time. I'm going to pattern this solid, and for direction 1, we're just going to go in the positive Z. And so we configured this ahead of time, so we can come in here to the list parameters and we can do barb count. But we don't want to do all 6 on this side, so we can say barb count divided by 2. So it looks like I got on my field somehow. So barb count divided by 2. And then for the spacing, we also had that parameter we created, barb spacing. So we go ahead and hit OK, and now we've got our barbs. So we actually had this as 3 different solids. To finish up the part, we're going to build it as 1. So you're going to grab this combine tool in the middle of the modify panel, and we're going to combine all of these into 1. So we're just going to do a straight up join, click all 3 of them. The tool body and the base really doesn't matter in this case, and I hit OK. And so now we've gone from 3 solid bodies down to 1, and we can now apply that fillet. So I'll just apply a fillet really quickly to this edge. I don't really care. Let's say, yeah, sure, 1/8 is fine. We can always measure that if we needed to. And we've got a hole, we've got the fillet, so I'm going to do one more pattern, this time a feature-based pattern, where I'm going to pattern the fillet and my cut. And so I'm going to choose, again, the Z direction. And the nice thing is, once you've entered in this data once, it usually remembers. So I can do barb count divided by 2, and then click the arrow again, and it remembers barb spacing, and then I hit OK. So now we should be good to go. We've got a really nice part. We've got half of it ready to rock. And so the last step in the process, we can use the mirror command. So if I click on the mirror tool, I'm actually going to mirror the entire solid. And one nice addition, I can't remember if this is in 2017 or 18, but they actually just show you the plane now. So I can just say, yeah, I want to mirror it right about the XY plane. I don't even have to turn it on or hunt and peck for it. It just throws the origin planes right here. I do want to join it as the same solid, and I hit OK. And now there's our part. So I just can turn off some of these work features, just the visibility, and that is your 6-port manifold. So again, a little bit lengthy tutorial this time. I suppose I could have broke it up into 3 parts, but it just seems so natural to do the second part all as one. So realize that you can extract solids from third-party parts. Either you download them. In this case, I downloaded from McMaster Car. And then using the tools within Inventor, I can build a part that maybe there isn't a model of in you can't find it anyway wherever you go on the website. So I built a couple of these now, and I've posted them on my GrabCAD page, so feel free to go check them out there, a 6-port and an 8-port. We'll see what I end up with. But again, this is just a simple way to work with geometry where I don't have the specs, but if I have a reliable source, I can extract the data I need to build the final part. So I hope you found this helpful. If you have any questions or comments, please let me know. Otherwise, have a most blessed day.